Hi everyone, welcome back to the final part on kinetic model. Now for this section, again we're going to keep it qualitative, and this time round what we're going to do is we're going to keep the pressure constant as we vary the temperature. Now if you're going to keep the pressure constant and we vary the temperature, naturally the volume is going to change. So we're going to explore how and why the volume changes. So for a start, let's observe the number of collisions between the walls and the molecules per unit area. Also observe the number of collisions between the molecules and the walls per unit time. And observe the speed at which the molecules collide with the walls. And this time round, take note of the average distance traveled by the molecules between each collision. Now first things first, I'm going to decrease the temperature. Before I go to that, please download the link below if you want to explore this applet any further. Now I'm going to decrease the temperature. And what's the first thing that you observe when I decrease the temperature? Okay, the first thing that you observe is that the average speed of the molecules actually decreases. Now it may not be very obvious to you, but what you need to do is isolate a section of this chamber, and then you can see that the average speed of the molecules actually decreases. And the volume of the gas starts to decrease. So if I were to isolate a small section of this chamber, I also notice that when the volume decreases, and the average speed of the molecules decrease, the number of collisions per unit area actually increases. And the number of collisions per unit time also increases. But the force at which the molecules collide with the wall decreases. So since the number of collisions per unit area per unit time increases, and the force at which the molecules collide the wall decreases, in this way the pressure of the gas is kept constant. Hence, when temperature decreases, the volume of the gas also decreases, provided the pressure of the gas is constant. Next, I'm going to increase the temperature and observe the average speed of the gas, the molecules. Right, you can see that the average speed of the molecules has increased and the volume of the gas increases. But take note that the average distance between each collision has now increased. Okay, average distance. So if I were to isolate a small section of this chamber, I also notice that the number of collisions per unit area decreases. The number of collisions per unit time also decreases. But note that the average speed of the molecules has increased already. So therefore, the force at which the molecules strike the walls of the chamber also increases then. So number of collisions per unit area per unit time decrease, but the force at which the molecules strike the chamber increases. And hence the pressure of the gas in this way is kept constant. So to summarize, as the temperature increases, the volume of the gas also increases, provided the pressure of the gas is kept constant.